Like I have a glass bottle of it.
Yeah.
And
Okay.
putting it on your feet.
That might be one or two.
Actually, yeah.
There's two.
Like you want to think that there's something.
There might be two there you want to check.
Before city, yeah.
I think there's three. Double check. Two there. Aha, perfect. Okay, good. All right. Now, what I want to do today, hopefully do you have 4 actual graphs there if you like flip it over? Okay, that's kind of my goal today. Hopefully none got cut off a little bit. The goal today is to do 4 different style of graphs. Some of them you've definitely seen, some of you have not. I want to make sure you kind of know how to do it. That's what we're going to be looking at today. The first one will be somewhat kind of easy, and then the next ones are going to kind of ramp up a little bit. But I want to make sure that we understand the concepts here. So, number 1, let's talk about the outline today. The section we're in 1.4. We're going to be talking about linear functions. Okay, perfect. Just put it back there. Okay, we're going to talk about linear functions and kind of the concepts of what we're doing with those. And so we're going to be looking at the 5 types of linear functions. So that's what we're going to look at today. Now, obviously, we're not going to do 5 graphs. The goal today is to like introduce them, or review them, I should say, because you probably covered them in Algebra 2 and Algebra 1, but that's been a while. So we're going to try to review those, the different types. So in fact, I'm going to just write these types down right now. These are the main 4 that I want you to know for sure. So number 1, point slope form. We have slope-intercept, which is the one that they probably talk about the most in like Algebra 1. Standard. Standard form is the one that we use in Algebra 2 a lot for like systems. And then number 4, this one's called general form, which I don't know if you've actually seen that form before. That's the one that we use here in PreCalculus quite a bit before we factor. That's why we have that form. But these are the 4 types. There is a 5th type, which I was talking about, and these are like the special cases. I'm just going to put special cases, which is like a horizontal line versus a vertical. What do they look like? How do you're supposed to graph it, that type of thing? How do you know which one's which? So those are your 5 types. Now, I know that's kind of a review. Most people probably know it, or they at least have an idea of how to go through that. But the problem is, we also need to apply this to, after we're through a few examples of these, my goal is to go through about 4 different types of problems so that you can kind of see how to work them. But the last part that I want to finish with today is called piecewise functions.
I hate these.
And the idea here is that the piecewise functions usually contain some form of a linear equation at some point. We'll talk about how I look at them, so it makes them a little bit easier. But it's going to mix in some of the more difficult stuff we've been doing in those last couple sections, where you have to actually plot points and see kind of where things are going. And so that's one I want to definitely discuss today. So questions, comments, concerns on kind of the goals today? Okay, the goal is to get through at least 4 graphs today, 4 that you can actually look at, you can see how to do them. You will need normal notes. Now, you're not going to be able to put all your notes on that little piece of paper. That's just when we get to the ones I want you to try out by yourself. So if you want to take out your notes, I'll give you a few seconds here. Take out your notes. We'll kind of go through a few examples first, and then we'll get to the ones where I want you to graph. I'll kind of warn you that I want you to try to graph this one on your own, or take some time. So the goal is to end with 4 on your graph that you actually had to attempt yourself. I'm going to go through this pretty quick. That way I give you a little bit of time today where you can actually work. So the goal is to give you about 15 minutes or so of work today. Because you had that homework assignment I gave you Friday, page 172. Alright, we're going to have time to get open up. Alright, here we go. Let's go through the first example. Remember, these I don't want you to put in your graphs, just kind of watch. Let's talk about the different forms of linear functions. So the first type is called point slope. Point slope form. Now, the reason why we have point slope form, it's usually when you have some form of data, or data, however you want to say it, and what you need is you want to go to some type of formula that represents it. So you have data and you want to go towards the formula that can represent that type of data. But again, this is still linear. right? It's still representing a line. So if there's any type of curve, that's a different situation. We can talk about those later at a later time. But the form itself, the formula, is pretty basic. Here it is. I don't think it's too difficult. I'll show you kind of where it's based off of here in a second. But this is the formula right there. So if you want to write that one down, that's probably a good idea. This is something that for me, it's my go-to if I have a bunch of like coordinates or I have information I need. Because if I have this form, like I take all my data and I plug it into this, I can then rearrange it to the other ones. So that's why it's always my first one I try to go towards. Now, what these parts stand for. Obviously, M stands for slope. Now, in pre-calc, there's two types of slope, which I know is kind of weird to ever think about. I'm not talking about negative, positive, 0, or undefined. There's 4 actual slopes. I'm talking about the categories of slope, not the types of slope. The categories of slope, that there's an average slope and there's an instantaneous slope, which is a different situation. That's like a calc versus pre-calc concept. What we're talking about is quote unquote an average slope. I want to show you the difference. Okay, an average slope is what we're doing, is where, let's say you're on a curve. I know we don't have curves today, we're doing a bunch of linear stuff, but an average slope is finding 2 points that are on the curve, so this point right here and this point, and an average is drawing the line that's straight through them, like that. It's kind of the average where that curve is going. That's a linear equation, right? That's the black line that I've drawn there for that curve. It's picking 2 points just somewhere, and you're finding slope and going from there. Instantaneous slope, which is something that you learn in Calc 1, is where you pick a certain point. You pick a point like, let's say 0, 0. That's right on that curve, that right curve there. And you're actually going to find the exact slope at that moment. Where, it may not be perfect to this black line, like these may not even look the same, they might be like tapered together because of just where I picked the point. Because if I were to slide this point closer, this line would be more steep. So an instantaneous slope is the exact slope at that exact moment, and how they find instantaneous slope is they pick points that are insanely close together. Like, the closer the points are, the more accurate the slope is at that exact moment, and that's what we do in Calc 1. You are focusing on just the average slope, so it's that black line there. So that's the concept we're going towards. Hopefully that kind of makes sense. But that's slope, so it's M. And then the rest of these, the actual coordinate that we have, that we're going to use, the coordinate, is x1, y1. That's the coordinate that you have. The other variables in that formula, like the x and y without the little ones on the subscripts, those are variables. We're going to leave those alone. So you're going to have numbers here, here, and then the m will be your fraction, whatever it is, your slope. Now notice, on the formula, what do you notice that's in front of your x1 and y1? What operation is in front of it?
Subtraction.
Yeah, you have to subtract. Whatever the number is, whatever your coordinate is, you have to subtract them. Even if they're negatives, you still subtract the negative number. It's the number one thing people get wrong when we actually have to do homework. It's the one thing I'll check and I'll see that, oh, you've got negative signs. Because you forget that you have to subtract whatever those coordinates are. So let's do an example here. In fact, let's do the 2 examples I've picked here. Pick something that was really close to that. Let's say, and again, don't put this on your graph. We'll just kind of write this down for right now. Let's say that this is my linear function. That's my line. This coordinate here is 3, 2. And this coordinate right here is -1, 1, 2, 3, 4. 1, 2, 3, 4, 5, -5. Okay, so -1, -5. Okay, so in your notes, let's find slope first. What is my formula to find slope? What do you remember? What do we put on the top of slope? What? Say it?
Rise or run.
Yeah, rise or run. So it's rise, how far you're rising versus how far you're running. It's basically drawing a right triangle. That's what you're doing. You're figuring out how tall you went versus how far you've run to that point. But how you do that, how you find a rise is the difference in the y numbers versus the difference in x's. That's the rise is y numbers. So in my case, it doesn't matter the order you go. I'll just take the top one minus the bottom one. I'm going to use the y numbers on the top. So this is not unfortunate. Might just have to get rid of that. And the network just went down. Oh, it did. That's why. Oh, come on. That's stupid. Whatever. Network went down. Turns off my Apple TV. All right. So, let's see. It's somewhere around there. Okay. All right. So 3, 2, negative 1, negative 5. So we're going to subtract the top one minus the bottom one. So let's go to 2 minus the negative 5. Again, you're subtracting whatever the two y numbers are. It doesn't matter if you went bottom up, top bottom. I just pick. So I'm going top down. So 2 minus the negative 5, and then the x numbers are the 3 minus the negative 1. Now, when you committed to that, and I chose to go with the top first minus the bottom, you have to stick with that for the second one. We have to do the y numbers first, and then the x numbers second. Y's are in the back, right, alphabetical order. So this turns out to be a 7 on the top, is 2 plus 5. And on the bottom is 3 plus 1, which is 4. There's your slope. Okay, so it's 7/4. You're rising 7, running 4. That's the idea. Some people just count their fingers. You're fine, you can do that. But sometimes it's nice to see the fractions, so you can simplify it from there. But plugging those numbers in, I'm plugging in that 7/4 here. So now I have y minus a y number, my 7/4, and an x minus an x number. So this is the formula that I'm trying to get to. Now, the y1 and x1, it doesn't matter which one you pick. In fact, you pick one of the two coordinates. That's how it works. So, do you want to pick the top one or the bottom one for the coordinate? Top. We're going to pick top. 3, 2. Okay? The 3 is the x number, the 2 is the y number, and you have to subtract. There you go. There's your answer. If you chose to use the -1, -5, you're fine. You would have had the exact same formula, 7/4. You would have just subtracted the -1, and you would have just subtracted the -5. And so this would have actually turned out to be +1 + 5. That's how you work it. It's still the same answer. In fact, I'll give you points for either one of these. They represent the same line. Questions on point slope form. Okay, here's what I'd like you to do. On your graph, first graph of the day. So put your name on it. Put your name on that graph paper. I'm not going to leave that up here. Here's what I'd like you to do. Your example. I want you to graph the coordinate -3, 4. I want you to graph the coordinate 7, -2. There's your two coordinates I would like you to draw. Put that in one graph, like draw the dots, draw the line that connects them. Oh yeah, sorry. So -3, 4 and 7, -2. So I'd like you to draw that in your graphs. And I would like you to try to do all the work that we just did here. Find your slope, figure out your equation. I want to see what you come up with. As you're doing that, I'm going to try to get this graph working and see if the network came back up. Leave all my work up there so you can use mine as an example. Actually, it's pretty close on that. Right.
-2.
All right, so hopefully you had enough time you could draw. Sorry, I'll try to provide rulers next time we do this. Sorry, I didn't even think about that. I should give you a ruler. So you can actually draw accurate lines, or at least just straight edge. All right, somebody you want to talk me through? What was your slope?
3 over negative
3 over negative 5. Anyone disagree with 3 over negative 5? Okay, let's talk about it. 3 over negative 5. Why? What were the numbers you subtracted? On the top.
Numbers.
Numbers? Which numbers?
Here.
4 minus negative
4 minus the negative 2. Okay, good. The y numbers have to go on the top. If you're thinking about like the most common mistakes people make on slope, they forget which numbers you have to put on the top. You have to put y numbers, rise numbers. Bottom, which numbers do we subtract?
-3 minus 7.
Good. You had to stick with that direction. You chose to go top minus bottom. You better go top minus bottom for the x's. If you suddenly switch around and go 7 minus negative 3, you just got the wrong sign. You have to go the same direction. So you're going to get that 6 on the top. You're going to get that negative 10 on the bottom, and this does simplify to be this. I don't care which one you chose. If you didn't simplify it, you're still good. I don't really mind. I think this is a lot easier when we get to later problems. Like to simplify, where you divide both numbers by 2, but it really doesn't matter. Now, final answer. Somebody else now. What was your final formula that you had? So can somebody tell
Y
me?
minus 4 equals negative 3/5, parentheses x plus 3.
X plus 3. Okay. Anyone have something different than that? That is correct. That's one of them. What would be the second one?
5 minus 7 equals 3/5, -3/5, parentheses, x plus 2, parentheses.
You have the 2 and the 7 switched. So, because the y has to be that negative 2, and then the x has to be the 7, because the 7 is an x location. So the x has to be at that 7 quarter. Yeah, you'd have been right. We subtract the 7, you subtract the negative 2, this is what you get. They're equal. They're the same line. If you're graphing Desmos, they still come up with the same answers. Okay, questions at all about what we're doing here? All right, perfect. Now, let's go to the second part here. This one I want you to put on your graph. I know that I said we're gonna do 4. I don't think we're gonna get to 4 today because I want to give you some time where you can actually work on your homework. But this is our last problem of the day. Last problem of the day, so that way you get some time when we're actually working homework. I want to talk about piecewise functions, but I want to do it with one of these forms today. So we'll go slope-intercept form, so it's kind of easy to look at, okay? Because that's the next form, and it kind of makes sense when you start graphing. All right. So slope-intercept form. Now, the reason why we have this form, it's really nice. You have a formula that they give you, so we have a formula, and what you need to do is we need to go graph it. That's the idea. They gave you a formula, and you want to go draw the picture from it. It's not going the other direction where you had data or you had a formula, and then you have data and then you want to go back to a formula. This one, you have the formula, and you need to go towards that graph in the first place. The formula looks like this. Y equals mx plus b. Let's talk about the parts. This is like the go-to version if you want to draw, which is perfect for what we're going to go into next, that piecewise function. M. What does M stand for? Slope. Average slope still. So y minus y, x minus x, it's still a slope. The b. B is just a random number. It's a digit. It could be positive, negative. It could be a decimal. It could be a fraction. I don't really care. But what does B stand for?
Y-intercept.
Yeah, it stands for the y-intercept. The y-intercept. It's basically what I think of. It's the starting point. It's where you should start on the y-axis and then use your slope to go from there. That's the idea. So you have everything you need. You have a coordinate and you have slope, and you can use rise or run to go from there. This one really requires that you understand that concept that we said earlier today, the rise over run concept, to know where to go. I usually always go like up or down and then go to the right. Always to the right. It doesn't really matter, you can go backwards, you can go up or down to the left, but I think it's, if you always think that you want to go to the right, you'll always get the right picture. So let's do an example. I'm going to do a piecewise function. So we're going to put this on our graph. This should be the second picture today. We're going to do a piecewise just so we can kind of introduce what I want to do here. So I can show you why it's kind of simple. All right, a piecewise function by definition is where you're drawing two different pictures on one graph. That's, or more, should be two or more functions. They all have their own domain, like over the set where you're going to be drawing. So for instance, so this is how the notation looks. So f of x, so that means you're using the this whole thing is called f of x, it's using x's. And then they usually put a big bracket, like a curly brace. And then they can have a bunch of different drawings in here. So like for instance, it could be 2x plus 1, it could be a negative 4x, and it could be x plus 7. And what they'll do is they're going to have different sets and domains. So like for instance, these are for all the x's that are less than or equal to negative 3. These are all the x's that are between, that are greater than negative 3, but less than 1. We'll put less than or equal to 1. And these are for any x that is greater than 5, let's say. And what this is it's drawing three different pictures. They're all, by the way, they're all in this form. That's what I gave you. It's all in this form. And they have you drawing three different pictures over three different sets. So I'm going to try to draw each one differently. So I'm going to try to color code as we go. So the first one I'll put in green. Next one I'll put in blue. And then I'll put the last one in black. You know? I know you guys don't have the luxury of doing that, but at least you get to see like why I'm drawing certain things. Okay? They are all in slope-intercept form. So like for the first one, what on the green one, what's my slope? On that?
2.
Yeah, the slope is 2. It's 2 over 1. Because that's the number in front of x, 2 over 1. And then your y-intercept is this number. Now, here's the problem. We may not get to the y-intercept. You may not get there. Because this thing says I can only use numbers that are less than or equal to negative 3. Negative 3 is here, and I can go only less than that. So my graph is going to be this side. So you have to think about, like, I'm doing three distinct pictures. That's the concept of what I'm doing here. So I'm picking any numbers less than or equal to negative 3. How I would do this, if it's less than or equal, that's what the little bar means. That means I can include 3. So I'm going to have a solid dot there. Let's plug in negative 3 into this thing, and let's see what happens. So, because these are all linear, there's no squares or cubes, so it's going to be pretty straightforward. So, if I were to plug in negative 3 in here, what happens? Negative 3 times 2 plus 1. What do you get?
Negative 5.
Negative 5. So, negative 3, negative 5. 1, 2, 3, 4, 5. Boom, and there is a closed circle. Why it's closed? I can actually equal that number. It can be equal to wherever negative 3 is. Now, I have to still keep picking numbers that are less than negative 3. That was the first number I chose. Now, if it said it had to be strictly less than negative 3, I would still start at negative 3. I would just have an open circle there. But I have closed because that can be equal to it. So let's pick a number. Pick any number that's less than negative 3.
Negative 4.
Negative 4. Okay. We plug in negative 4. Negative 4 times 2 is that negative 8, and then add 1. Negative 7. So that's here. So at negative 4, it's negative 7. And here's my line. And I'm going that way because I can go, and it's linear. We know it's a straight line, so you only have to draw 2 points. And that's the definition from geometry, that a line is composed of any 2 points and all the distance between them. So it's a ray because this thing stopped at negative 3. Okay, does that make sense? That's how I think of like piecewise functions. I want to know where the starting point is. I want to know another point, and hopefully it's linear. If it's curved, I'm going to have to draw a lot of points to kind of see where it's going. Let's do the second one. So the second one, it's still a linear equation, right? It's negative 4x, that's my slope, is negative 4 over 1, and then it's plus 0. So if I could draw over the origin, I could figure out that I should be going, over the y-axis. I will be hitting the origin, and it looks like I will, in fact. But what I would do on this one, since I know it's linear, just plug in the first and last number on whatever domain they tell me. That's like the easiest way to do it. So if I were to plug in a -3 in here, what's -3 times -4? Positive 12, right? And since I cannot include it, there's no bar here, I'm gonna have an open circle right there. So at -3, my answer was positive 12, and I'm gonna have an open circle. Because I could not include it. It had to be strictly greater than -3, so it has to be an open circle. Now, the next number I'll plug in is the 1 here. And I'm gonna have a solid dot at 1 because I can include it, I can equal 1. So what's 1 times -4? -4, right? So 1 comma -4, and I'm gonna have a solid dot there. So here's my picture. Well, I miscolor coded, oops. Should use blue. Alright, we'll make it work. Okay, questions? Now it's linear, right? There's no curve, it's supposed to be a straight line. It hit 12, it hit -4, I drew the line straight there. And how I'm graphing those dots, it's whatever number I plugged in, comma, the answer that came out of it. So, sorry, I probably didn't state that earlier. That when I plugged in -3, it gave me an answer of 12, that's the coordinate I drew. And I made it an open circle. That's why that dot was up there. Because that was the first number I could use. Sorry, I forgot to state that. It's kind of an obvious thing. Okay, let's do the next one. This next one has to be in blue. What number should I start with? Say it again? What number should I start with on this next one? Plug in 5. I know this is the starting point, like if we were drawing the whole line, I would start at 7 and kind of draw from there. But you need to use the domain, whatever numbers they tell you. So I'm going to use this first number. Now, is it going to be an open or closed circle there? It'll be an open circle, right? When I plug in a 5, what answer comes out? 12. So 5 comma 12. So 5 over 1, 2, 3, 4, 5, and go up to 12, and there's going to be an open circle right there. Now, why it's open, I can't include it. I'm supposed to be strictly greater than 5, so like 5.1 would have worked. So that's why we're using that number. That's the starting number. Now, let's pick any number that's greater than 5. 6, good choice. So we plug in 6, and when we plug in 6, it looks like my answer is 13, and that would be a closed circle. So 6 comma 13, and there's where that one's going. So we have 3 different distinct graphs going here. It is a function. The reason why this is a function, it passes what we call a vertical line test. We'll talk about that later. Okay, so that's your last one today. I would like you to hold on to this graph paper, put it in your notebook, maybe use it as your bookmark today. We're going to try to do a couple more graphs tomorrow on Piecewise, but we have to go through these other forms. Questions? Yes. All right. So there you go. Okay, the rest of the time is yours. You have about 15 minutes here.